Okay, these are the guided notes for the hypotenuse leg congruence shortcut. So this only works for right triangles, which is why we use hypotenuse leg. Otherwise, it would be an SSA pattern, which only works for right triangles. So if you have a right triangle or two right triangles and you can show or prove that the two hypotenuses or two hypoteni are congruent and two of the corresponding legs are congruent, then by hypotenuse leg, you have enough to prove that those triangles are congruent, which means that all 6 parts of those triangles are going to be congruent, just with the shortcut of showing that it's a right triangle and that you have a hypotenuse in a leg. So this SSA pattern does not work for other than right triangles, which is why we call it hypotenuse leg, to remind us it only works for right triangles. So if we look at number 1, I can see that there's a side angle pattern, and we want to label the congruence in the correct order. So C goes with F, A goes with D, and B goes with E. So we have to name that congruence angle or triangle F E D, and they're congruent by angle side angle. If we look at number 2, we have two right triangles, so we're thinking about maybe hypotenuse leg, and we see that the two hypotenuses are not marked congruent with each other. MA is the hypotenuse of the triangle MBA, but PD is actually the hypotenuse of triangle HPD, so we can't say that those two triangles are congruent to each other. So those two triangles are not congruent by hypotenuse leg, even though I mistakenly said that they were. Looking at number 3, we have angle, angle, angle. We haven't really talked about similar triangles yet, but all angle, angle, angle does is guarantee that the triangles are the same exact shape. It doesn't guarantee anything about the size or that they're congruent 1-to-1. We say that those two triangles are similar by the AAA similarity shortcut, which we will be doing a little bit later on. So we cannot say that those triangles are congruent. Looking at the pattern with number 4, we can see that we have a side angle side pattern of congruence between those. So NOM has to match with OPR, with QPR. Looking at number 5, we can see that there's an angle side-side pattern, and that angle side-side pattern, or we call it SSA to be more appropriate, only works for right triangles, so we cannot say that those two triangles are congruent with each other. So again, it only works for right triangles, and then we would call it hypotenuse leg. If we look at number 6, we've got 3 sets of sides matching, which gives us a side-side-side pattern, which is one of our congruent shortcuts. So we can say that triangle GIH is congruent to triangle KJL. And again, we're matching up the congruent sides to be sure we're going in the correct order. So let's see, G to H is 2 marks. So we got to go K to L for the 2 marks. And then from I to H, so we have to name it KJL. Okay, looking at number 7, we've got 2 right triangles. The two hypotenuses are congruent, and the two matching legs are congruent, so we can say that these triangles are congruent by hypotenuse leg. So first off, the right triangles, which opens up the possibility of hypotenuse leg, match the hypotenuses up, match the two legs up. Hypotenuse leg is enough to guarantee they're congruent. So DOM is going to be congruent to triangle TAB. If we look at number 8, we have a side angle side pattern, which is enough to say that these two triangles are congruent to each other. We're starting with M, N, O, so we need to do R, Q, P when we name the congruence. Looking at number 9, we've got an angle side angle pattern, and B goes with E, AB goes with DE, and A goes with E, B goes with D. So we have to be sure that we name the congruence in the correct order. So we get triangle EDF is congruent to triangle ABC. Looking at our number 10, again, we have another angle side pattern. So those triangles are going to be congruent. And M to N to O is going to cause us to have to go P to Q to R. For number 11, we need to prove that triangle BCD is congruent to triangle DAB. So we notice that BD is shared between the two triangles, so that's going to be congruent by reflexive. They're also telling us that CB is congruent to AD. That gives us a pair of sides. It tells us that CB is also parallel to AD. So with CB being parallel to AD, that sets up alternate interior angles. So the angles CBD and angle ADB are going to be congruent because of alternate interior angles. And that gives us the A part of the pattern that we need. And so altogether, we have an angle side angle pattern to show that those two triangles are congruent to each other. So this turned out to be a 5-step proof. The two givens could have been done in one line. It could have been 4 steps. Number 12, it looks what we have actually is an isosceles triangle because we have those two congruent sides. But they're telling us that PL and YL are congruent. That gives us two sides. Angles opposite those congruent sides are going to be congruent. So that gives us base angles congruent. Angle P and angle Y are going to be congruent. And then we also have that the shared side, LA, is congruent to itself. That gives us reflexive property. So we could go with side angle side, or we could go with side side side. They're using side 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 for this. So we're going to, let's see how we, point A is the midpoint of PY, so that gives us PA congruent to AY. That gives us a side. LA is congruent to itself by reflexive, and then we're given that LP is congruent to LY. So that sets up side, side, side congruence. Using isosceles triangles, we could have done those base angles, and that would have given us a choice of side angle side.